I know the next session is technically lunch, so I'll try to be quick so that you guys can go eat. I know what it feels like. So that's the question, why are we still using 1980s tech? So I want to take you back to 1986. It's a very fun year. We'll take a time machine, we'll go back to 1986. 1986 had wonderful aesthetics. These are the kind of things we were looking at in 1986. I'm sure most of you were around. There might be some people younger, but this is what was around in 1986. Pretty good year. This is state-of-the-art computing in 1986. Many people at home had an Apple II GS, or like I did, a 286 with a 20 megabyte hard drive and running DOS 3. By all accounts, very interesting technology. But that's not what businesses were running. Businesses were running things like this. Teradata DBC 1012. This is actually product of the year for 1986. And this was a really fantastic data warehouse. It's one of the first massively parallel data warehouses. Amazing. Estimated at 17.5 million euros per gigaflop. So that's what performance cost back then. And this was a fantastic product, completely life-altering for big companies. So on June 2nd, 1986, two very important things happen. The first of which is Teradata ships their first 1 terabyte solution. It came in that truck, so it's not a simple, it's not like a laptop you plug in. It's a big thing. They called it the big one. The other thing that happened on June 2nd, 1986 is I was born. So it's a very important date, and I hope that you remember this. So let's head back to 2020 now, because that's where we are. So performance is getting cheaper. It's not so much that expensive anymore. A gigaflop costs about 2 euro cent today. That's the price we're talking about. So the question is, why are we still using the very, very complex architectures that we had back then? All of these different data warehouses that we had back then when performance was expensive worked with what we call workarounds, or I call them workarounds. They're known as data warehousing techniques, where you, for example, correlate the data before it comes in so that you can analyze it later. You do a lot of cleansing. You do cubing. If some of you are still doing OLAP cubes, amazing. You have to create projections. You have to pre-aggregate tables. You have to index everything very, very meticulously. Otherwise, you're not going to get the performance. So these are valid. They're good techniques. But are they really necessary today? And the answer to that will be clear when I talk about that in a little bit. The problem with having all these workarounds where you kind of limit your analysis by creating an OLAP cube or pre-filtering and pre-aggregating is the people who actually need to run the analytics, they are limited. They cannot add more dimensions as they see fit because someone didn't design the database in that way. Now, this wasn't a big problem back then because if you have 1 terabyte of data that you collected and you analyze 1 terabyte, amazing, you've analyzed 100% of your data. As the data sizes grow, if the analytics infrastructure does not catch up, you're analyzing a smaller and smaller percentage. So 10%, if you have a 100 terabyte data lake and you're analyzing 10%, 10 terabytes, that's still good. That's still a fairly sizable representative sample. However, if your data grows and you're analyzing, let's say, 0.5%, but you have a competitor, no one here works in a vacuum, right? You all have competitors. You have a competitor that's analyzing 3% or 4%, they might be reaching more interesting conclusions than you are. They might be more agile, they might be more data-driven, and that's something that you cannot have as a data-driven company. So the point is, many valuable insights can go undiscovered. This is a common problem, especially as the data size and data collection grow. So Scream's goal, the company I work at, Scream, the goal is to make accessing more data easier. So the goal is not to just access more data, but to make it easier as well. I'm going to talk very, very briefly about our product, and then I'll show you why that's interesting. So it is a data warehouse. It's a DBMS. It's designed for very large data sets. It's designed for analytics, and it's powered by GPUs, which is a little bit of a weird thing. We're using graphical processors, the kind you would get from NVIDIA if you have a gaming PC at home, for example, or if you're doing deep learning. We're using that to access more data, which is a little bit different than what most people use it for. But that's the idea. The idea is to access more data. So It's a complementary product. It works alongside other products. It's not designed to replace the main data warehouse. It's designed to sit alongside and kind of enable that ad hoc analytics. We've also split it up so that we can grow it to different use cases, different lines of business. And the compute and storage are separate. This is in stark contrast to Hadoop, for example, where you kind of have to scale both together. I'd like to talk about a customer, though. I'd like to show you what this looks like in action. So one of our customers is a company called AIS. They're the largest mobile operator. They're based in Thailand. They have just over 41 million subscribers. By European standards, that's quite a lot. By American standards, for example, not so much, but you work with me here. AIS are the largest mobile operator in Thailand. As a large company, they're a little bit slower to move compared to a smaller company, and there's a few of them. There's a few other mobile operators. And they were starting to grab customers from AIS. AIS were feeling this churn. They're saying, we can't respond as fast as the smaller companies can. And that's exactly what I was talking about. Not being able to look at the data, not being able to analyze the amounts of data that they needed, kind of stopped them from running marketing campaigns, from segmenting their customers properly. So they had few issues that they brought to us, basically, and they said, it's really hard to scale our current solution. That's granted. We're spending many, many hours overnight, every night, preparing the data. There's massive data preparation tasks that they would like to get rid of. I'm speaking for them. There's potential data loss as well. Sometimes the processes don't finish in time, and if they don't finish in time, they just get killed. After 8 hours, if a report is not finished, it's gone. The result of all of this was basically, frustrated business people, frustrated data scientists, frustrated BI analysts, because they're saying, the company wants us to be data-driven. They want us to reach conclusions based on the data, but we can't, because we can't even get the queries running. So they couldn't live up to the company's goal. So we were called in, and they had a few requirements for us. They said, it needs to be usable by everyone. We don't want Scala code. We don't want to deploy MapReduce jobs. We want it to be used by anyone. We want it to be easy. We want it to fit into the existing ecosystem, granted. It needs to be expandable. It needs to handle lots of data. And we want a partner with who we can innovate with. We want someone who can respond in weeks instead of years. So with that, we set off to Thailand. And the first thing we produced, and this took about 3 days end to end from the moment we arrived until we showed this, is a Tableau dashboard. Tableau, amazing. What you're looking at is a live, it's not live, it's recorded, but it was a live view connected to ScreamDB. We're doing an aggregation of a three-way table join between 3.3 billion call records, 40 million subscribers, and 300,000 locations. I was there for this, so this is something I hold very dearly. I was there for this, and once they saw this, there was complete silence in the meeting room which we were in. I don't understand a single word of Thai, but then a whole lot of chatter started, and they started hammering us with questions. Can you show us diamond subscribers? Can you show us platinum subscribers who landed in Phuket and then took off from there? Can you show us a traveler who arrived in Bangkok? Where did they stop using the SIM? Why did they stop using the SIM? Can you show us the network performance across these different profiles? And so on and so on. The point is, once you start getting access to data, it's really hard to take it away, because suddenly you have all these questions that you want answered as data professionals. So that was the first thing that we showed them. It's kind of important that I show you what the solution looked like, so that's what I'm going to do now. We were up against an incumbent product, Greenplum, columnar database, MPP as well, very good product, but it was a little bit stretched at this point. So overnight, it would take about 7 hours to load the data and prepare it and produce the reports. This 7 hours is important because on holidays, people talk more, people use more data, people travel more, and then that gets longer and longer. At some point, over weekends, over holidays, this can go up to 8 hours. Remember what I said about 8 hours? The moment it reaches 8 hours, the process is killed. And then they don't have the report for the day. So then they have to wait for the monthly report. We'll talk about that in a second. We showed them that we could do the same thing in about 30 minutes end to end, which is pretty nice. They were really happy with that. It's also important to show how we did that. I mentioned we're GPU accelerated. So we were actually running this off a single server with a single GPU at the time. This was for the initial project. And we were up against 7,600 CPU cores. That's what I mean when I say, technology has gotten us to a point where we can actually write better code. We can easily write better code that's a lot more performant. And for many products that were architected in the 1980s and 1990s, they're not built for that. And then you get this kind of workaround that you have to keep producing. You have to keep pre-aggregating and indexing and so on. So this is how the architecture looked before we arrived. The daily aggregation part, that is the part that takes another 5 hours. So 5 plus 2 plus a bunch of other stuff, and then you have the daily reports that run. So I mentioned the daily report takes another couple of hours. For 7 days during the month, they also cordon off a bit of the system. They partition the system and they say, this part of the system for this week is going to be spent preparing the monthly reports. This cannot be preempted. This has to finish. The fastest report that they have runs about in about 30 minutes. The slowest takes 5 hours. 5 hours, it's quite a long time to wait for a report. We simplified it a little bit because our architecture does not need the same level of pre-aggregation, the same level of all that data prep. There is some data prep needed, don't get me wrong, but not to the same extent. We were able to load everything in 25 minutes. That's per night. Yeah. The monthly reports, the slowest one, which took 5 hours, now takes 10 minutes. So we've taken half a day's worth of process and brought it down to a long coffee break, give or take, or bubble tea, whatever, in Thailand. That is what we like doing. We like taking these very, very long processes and shortening them to what we call human real time. The end result of what they actually do with this data is they're able to segment the mobile market a lot better. They're able to produce a lot more packages that are actually based on analysis of real customers. So they're not just making stuff up anymore. They're actually basing it on real values. This helps convert customers to better plans, not just better for the company, but also better for the people. This helps customers feel seen, and that's really, really important when you're dealing with people. You have to remember it's people. It's not a subscriber, it's a person. That person needs to be felt. They need to feel like the company is behind them. Otherwise, they'll just go to the competitor. If they offer it for 20 less baht per month, they'll just go there. We've actually expanded the project there several times, and I mentioned that ScreenDB is designed to be like a main data warehouse with different lines of business. That's something that we've actually done there. So it's used by marketing, it's used by the network engineering department as well, and they're combined with Ookla speed test. They actually try to get the best throughput for the entire country, and they use ScreenDB with Ookla to kind of get the best performance throughout the country. And they are the network leader in Thailand. So we're happy to be part of that as well. So that's kind of the ROI, right? It's kind of hard to quantify because you're saying, they did spend money on our product. It didn't replace an existing product. It's not that we pulled out Greenplum and put ScreenDB and everything was magical. We do sit alongside the existing product. But the reduced churn and just, the fact that they are the market leader in Thailand with our help it's really hard to quantify how much that's worth while we're here on the ROI track, by the way. There's another thing that we've done with a bunch of other companies. This is kind of more of the same, but I do want to talk about the different use cases of this. We're doing DNS backdoor detection together with Elastic and Kibana, where we are actually the pre-aggregation step. That thing that I said that we don't usually need, we don't need that with ScreenDB, but other downstream products sometimes do. So we can do that. That's something that we do with one of the companies. In another company, what we do is we've actually displaced Hadoop Hive. So we're actually used as the main data warehouse for AI. That's something that we do. In another situation, we're powering TensorFlow and Tableau. In another situation, we're just analyzing the call defects for another mobile operator. And in another situation, we're actually used for compliance, where they're checking the results from Hortonworks and checking that they're accurate with ScreenDB. So, that's basically it. That's what I wanted to talk to you about. I promised I would be faster so that you could go to lunch, and I'm keeping to my promise. Unless there's any questions, that's pretty much it. We have a booth outside, by the way, and you're free to come to us and talk to us a little bit more about this if this is interesting. And if not, just get a stamp so that you can get the speaker, which looks really good, and I can't get it because I didn't get the paper, which makes me feel terrible. Are there any questions? That's usually a good sign.
I got one from my side. So what is your biggest takeaways from this project in Thailand?
So we kind of went in there not really knowing what to expect. We went in there without knowing what the infrastructure looked like. The moment you show the value of data, the moment that you can produce something valuable to them, as I said, we showed the Tableau dashboard first. That was the first thing that we did. As I said, the opportunities are endless. And I think the second that they saw that, the second that they could start asking their own questions, and they did, and we showed them a bunch of dashboards during that day, during that meeting, that's when it was sold. That's when they decided, okay, this is what we need. Because they could not get that with the previous system because it was so difficult. And there were political reasons for that as well. When you're working in a big company, I'm sure some of you know this, you want to add another dimension. You want to add that to the cube, or you want to create an index on that. If the data is really large, that becomes prohibitive. The company says, no, we'll have to acquire more disks. That means we'll have to start procurement. We're not doing that. So we're not exactly solving that situation per se, but that's a problem that a lot of customers face. Not just the technical issues, but the political issues as well of internal company politics, really, of getting access to the data. And that's what we like doing. We like getting the data to the data analysts without that intermediate, without having to go through the whole data engineering pipeline and having to create the indexes and all that stuff.
Makes sense. So guys, last call for questions. Anybody?
Did I speak too quickly? No.
Okay.
So you mentioned about GPU.
Yeah.
And that you use this hardware, but in fact, I don't care about the hardware. I more care about the service. So are you exposing this through is it a cloud native service, or it's like on-premise, if I would like to use it?
Yeah. So you don't need to care about the GPU. I'm explaining it to you because I need to tell you why that's different, right? Why we're able to do what we do. I can't say, we just wrote really good software, which is also true, but it's not enough. So that's why the GPU is there. Users don't know about the GPU. They don't need to know about the GPU. They write a SQL query, they get the results. That's all that matters. The person buying the hardware for on-prem does need to know about the GPU because they're going to have to install it. In the cloud right now, we work on EC2 and those kinds of situations where we're running kind of almost like bare metal, but in the cloud. We're going to have a service later this year where that's a complete service, but that's towards the end of the year.
Okay, thanks.
The good thing about the architecture, what I showed with splitting the storage and the compute, that's what enables that. The fact that we're able to use a big centralized storage like S3, like Google Cloud file system, right? That allows us to kind of not care about what's underneath, and we can just, you're running one query, you only need one worker, you only need one GPU at a time. If you have 100 users, you may need some more GPUs, and then that comes in rather elastically. We can do that on-prem today. Cloud is a little bit more difficult. That's why it's coming towards the end of the year.
I'm looking, like scanning the room. If you raise a hand, it would be easier, but I can look deep in your soul, through your eyes as well, and I see that you have some concerns, maybe about lunch.
Some of our servers can run Crisis really fast if anyone's following.